Okay, in this video we are doing Calc AB Problem Set 85. The problems and a playlist are in the description below. Let's see what it looks like. So we want to evaluate the limit as h approaches 0, 1 over h, natural log of 1 plus h over 3. This looks a little weird, but let me tell you, problems that look exactly like this have shown up on older AP exams, like old AP exams, but still, it's a problem that's worth doing because that happened, right? So it's my favorite, weird definition of the derivative problem, actually. So what I'm going to do is just some algebraic stuff. So I'm going to look at the limit as h approaches 0. I'm going to get a common denominator inside that natural log. So I'm going to have natural log of 3 plus h all over 3. All over 3, I accidentally wrote h there. My bad. That was confusing to me, actually, because I said the right thing and then I wrote the wrong thing. So I guess I should fix it. I don't really want to. Here goes. Why did I write over h, 3. Okay. In the next step, I'm pretty sure I did it right anyway, so that's even weirder. All right, so now I'm going to use a property of logs where division inside a log becomes subtraction between the logs. So limit as h approaches 0, 1 over h. Now we're going to have a quantity, natural log of 3 plus h minus the natural log of 3. So somehow, even though I wrote h on the previous step, I managed to fix that, whatever. I'm going to rewrite this in the more traditional way that the derivative will look like, right? Like a fraction. So we have f of x plus h minus f of x all over h, where x is going to be 3. So we're really finding the derivative of natural log of x such that x equals 3. The derivative of natural log is 1 over x. So we're really doing 1 over x such that x equals 3. So our answer is actually 1/3. It's a very strange definition of the derivative problem, but that's all it is, definition of the derivative. All right, let's look at b, which is a little more straightforward. We've limit as h approaches 0, quantity 4 plus h to the 8th minus 4 to the 8th over h. This is definitely the derivative of x to the 8th evaluated at 4. So that's what I'm going to write. And then power rule that thing such that x equals 4. And then plug in, I don't think you would have to simplify something like this. I mean, it'd be unreasonable. I mean, maybe the answer would work its way down to 2 to some power. I think it's 2 to maybe the, 17th. But I'm just going to leave it like that because I think we accomplished the goal that we set out to. All right, let's look at the next problem. Write the equation line tangent to f of x at x equals 1/2 given. Now this is weird. F of x is a limit. So it's a limit as h approaches 0 sine, arc sine of x plus h minus arc sine of x all over h. So f of x is the derivative of arc sine. F of x is not arc sine. So f of x is the derivative of arc sine, and we know the derivative of arc sine is 1 over the square root of 1 minus x squared. So that we have that because we memorized it. You should definitely memorize that. Okay, so I'm going to find f of 1/2 now because I'm trying to write a tangent line. So f of 1/2 is going to be 1 over the square root of 3/4, or 1 minus 1, which is 1 over the square root of 3/4. Square root of 3/4 is square root of 3 divided by 2. So we have 1 over the square root of 3 over 2, which is going to be 2 over the square root of 3. All right, now we got to find f prime. So f prime is going to be a power rule situation. Also, I think it's probably better before you find f prime if you think of f of x as quantity 1 minus x squared to the negative 1/2. Then you can power rule it and chain rule it kind of more in your head. Radicals are terrible. Radicals and denominators are even worse. So just rewrite it. All right, so we're going to bring down the negative 1/2, 1 minus x squared to the negative 3/2, and then times negative 2x. So we have negative 1/2 and negative 2x. So that just gives us x in the numerator. And then our denominator is going to be 1 minus x squared to the 3/2. All right, now we need to evaluate this at 1/2. So f prime of 1/2 is just a tangent line problem. It's just the function started out a little weird. So we have positive 1/2 over 3/4 to the 3/2. I don't know what you want to really do with this. I mean, the square root of 4 is 2. So I'm looking at that 4 to the 3/2. The square root of 4 is 2, and then cubed is 8. So we have 3 to the 3/2 over 8 in the denominator. Multiplied by the reciprocal, we end up with 4 over 3 to the 3/2. I also, on the AP exam, you could get away with just leaving the previous step, I think. That would be totally fine. I just wanted to simplify it. And then our tangent line in point slope form is going to be y minus 2 over root 3 equals 4 over 3 to the 3/2 quantity x minus 1/2. So it's in the category of in my opinion, kind of useless tangent lines if you're not using a calculator, but that's what it is. All right, next up. Use the table of values for the continuous function f of x to answer the question. So if you only know a function is continuous, you would not anticipate mean value theorem, approximating a derivative. I mean, you can still approximate a derivative, but like there's not really a lot of justification for it. But in this case, we're just approximating definite integrals. So approximate the integral from 3 to 15 using a left Riemann sum. All right, so all of these are actually just 3 apart, which is great. I think that's the first time that's happened in the problem sets, because you shouldn't count on that. Like, don't count on just memorizing a formula. You got to really think, like, what are you doing? But for part A, from 3 to 15, f of x dx is approximately equal to. All right, so the base is going to be 3, and then we're doing a left Riemann sum, so the height's going to be 8. And then 3, left Riemann sum, so 4. And then plus 3, a left Riemann sum, so 10. Plus 3, a left Riemann sum, so 7. And we crawled all the way across. Like, that's all we need to do. For each of our partitions, we now have a rectangle. And then you could leave this on the AP exam, but in my class, and here I'm going to simplify it to get 87. Then we're going to do a right Riemann sum. The left Riemann sum and the right Riemann sum are very similar calculations. It's like what we need to do is kick out that first calculation we did and add another calculation at the end. That's one way of thinking about it, but I'm going to do it like all the way through. So it's 3. Our right endpoint is at 4. Plus 3, our right endpoint will be at 10. Plus 3, our right endpoint is at 7. And then plus 3, our right endpoint is at 4. So we get this, and again, you could leave it, but if you don't leave it, you get 75. Now, a really interesting thing it's not asked about here, even in the next part, would be the trapezoidal approximation. The trapezoidal approximation is the average of the left and the right approximations. So if we were to calculate the trapezoidal approximation at this point, we know that the integral from 3 to 15 f of x dx is approximately 87 plus 75 over 2, which is 81. So it's really important to realize trapezoids are the average of left and right. The midpoint sum is kind of on its own. There's nothing kind of related to it really as far as these other sums. So you got left, right, and then the average of left and right is your trapezoidal sum. The last question in this problem set, though, is actually the midpoint sum. You need a very specific table to be able to do a midpoint sum because you need to be able to actually find from the table the midpoints of the integrals, which is like hard to do unless everything is evenly spaced, which is the case here. So we're going to use 2 sub-intervals of equal length. So if they're of equal length, they're each going to have to be 6, right? So 3 to 9 and then 9 to 15. Both of those are 6. We're going to use that. So our integral is approximately equal to, we're just doing rectangles again, right? So it's going to be 6. And then at the midpoint, so from 3 to 9, the midpoint is x equals 6. At x equals 6, the height is 4. So times 4 plus another 6. And then the midpoint of 9 and 15 is 12. At x equals 12, the height is 7. So times 7. And then we have 24 plus 42. So we get 62 here. It's always interesting to look at all the approximations and see how they can, they vary by quite a bit. That's why we just accept that we're using this particular method on a particular problem. It's not like one is any more right to use than the other. You just have to know all of them. All right, that's the problem set. I hope you found this helpful, and good luck.